Hello everybody. Today I'm gonna tell you a little bit about React with Redux in combination. First of all, hi, I'm Nick. I created a React UI library with about 1,000 GitHub stars, which is called Bell. Check it out. I'm working with Starter Squad. I'm a freelancer. Starter Squad is a freelancer community, and because we're all remote, past year I had the chance to travel around the world. So it's a quick summary about me. First of all, the warning up front. I use ECMAScript 2015 in these slides because it's just way more concise. So this is a function definition. We generate the sum of the first and second argument. Who of you has used React or is going to look into React for his next project? Okay, a couple of people. That's good. So what is React? First of all, React is just a user interface library. React is not a framework, so you don't have things out of the box there like router or cookie support. It's just for UI rendering. One important feature of React is one-way reactive data flow, so you won't find out of the box two-way data binding, which might surprise you after all the Meteor, Angular stuff you have seen probably. And there's one really, really special thing about React. It has a virtual DOM. So why do we need something like a virtual DOM? The problem is with virtual DOM that keeping track of state in the DOM is really hard, but we still do that. If you look at jQuery date picker, you have a lot of data attributes or any kind of or other components. We do that a lot, and so it's really, really tough. And mapping your data model to DOM is also really tough because you can't simply say re-render the whole page every time. Because you get immutable data. So it's really kind of nasty because the DOM is slow, and so we try to do DOM operations manually all the time. And that's kind of annoying because it's a really bad situation. So the virtual DOM is actually an invention which helps you to map your data model to your DOM rendering. And it does it by basically injecting one layer, the virtual DOM, which is what you can do with React. You get a render function, and then you generate a virtual DOM, or what you do is you generate how your DOM should look like. And the virtual DOM maps this to the real DOM and then does the real DOM manipulations. So how does this look like in an example? If you have your data model on the left, you can see this one node, which is red here, change. So the virtual DOM from the previous state is the one you see above, and what the virtual DOM does it makes a diff. It figures out, okay, when the data model changed from A to B, then actually only this one DOM node has to change, and then the virtual DOM does the real manipulation for you. Why is this beneficial? Because it's simply way faster. In the background, it works with string comparison, and that's just way faster than actually fetching a DOM node, making a comparison, and then figuring out if we should do the manipulation or not. So that's the virtual DOM, and what it can do is it can actually figure out, okay, you have, for example, if you have one. If you rendered your application state and then you want to do a re-render of your whole page, and two things somewhere in the page change, the virtual DOM, it can figure out, okay, I just need to do two operations to change from state A to state B. And that's really efficient if you operate like that. Let me get right into a little bit of code. First of all, this is basic JavaScript. To get a feeling of like, okay, here we have a diff with an ID example, and there we used our compiled bundle.js, which we generate with Babel. It's a JavaScript compiler where we generate our whole source files. How does a React component look like? So the core of React is components. You can build components, you can nest them, and there's actually a pretty new syntax. So even if you have worked with React, you might not have seen this, but what's probably going to be the future or what is really popular amongst the React community now is so-called stateless function components. What it means, you basically just have to define a function where the returned value is JSX, and that's it, and that makes a component. And in this case, we import React, we create our profile component, we pass in the properties that belong to this component. The nice part here, you might haven't seen this syntax yet, but what it does, it's deconstructing right away in the function definition. So properties.avatar, properties.name right away get deconstructed into avatar and name. And then we simply have a return statement where we return our JSX. So I used the word JSX, or the term JSX. What is JSX? JSX is just a JavaScript syntax extension. It looks very similar to XML, and it allows you to write an XML-like syntax in your JavaScript directly. So you might think like, wow, that's breaking with best practices. Yeah, well, in this community, that's actually the best practice now. And yeah, just to let you know, it's not, I mean, you can't have that in your source code, in your JavaScript source code, but in the end, when we compile it, JSX is just compiled to React.createElement, and because you don't want to write that every time, therefore they created JSX syntax. And then we can import our profile component, and we can use it, and we can nest it. And in this case, as you can see, we have our app component, that's also a component. And so you can do various kinds of nestings, and you can very easily and beautifully construct your application. In this case, you also see when we, before what I showed you, we have here, we pass in the avatar and name, and that we can simply pass with our attributes here. And so in this case, I create a profile picture with test PNG and name Nick, and yeah, that's it. And there's a little bit of code just to render it into, we fetch the example div, as we've seen from the index before, and then we put our app component into the DOM. And the outcome is this. It's simply rendering, because as I mentioned before, React is just there for rendering. It simply renders the virtual DOM that we created with our component right into HTML. So if you remember, we had example, and then you can see here, app starts here, and the app ends here. It was a div. And if we go back to the profile component, you can see it's a div, an image, a span, a div. And that's exactly what gets rendered right into here. So React, if you use it with stateless function components, not much more than a fancy language, fancy templating language, but really, really useful because of when we look at functional programming, it has certain traits, and these certain traits are functional programming. In functional programming, you try to avoid changing state. You try to at all avoid mutable data. And a really, really important thing is that whenever you call a function twice with the same arguments, it will return the same results. Every time you call it, it will, and that is really, really important. And if you look at the traits from functional programming, and here to stateless function components, it actually has the same traits. So we can say when we just rely on stateless function components, we get all the benefits from functional programming. But why do we need that? Because it makes our code predictable. And predictable means it's easy to understand. You can look at something, you can look at a component, and it's whenever you just can analyze, okay, these are the inputs, and then you know exactly that's going to be the expected output. There's no like global state that is interfering and that messes up your brain. And the beauty of it is also that it's really, really easy to test. Because if you know I can call a function and it's always returning the same thing, then you just import it, write the test for it, and you ask for it compared to the expectation, and that's pretty nice. So by this time, you should be in that state, completely mind blown. Of course, we can also do flow control statements, which is in the end just JavaScript. So in this case, I've in my friends list to get past the list of friends, and I iterate over them with map, and in the end I just again return JSX, and there you can construct dynamic things. For example, in this case, I have my friends list, Max and Tom, and I pass it at the friends list, pass the friends, then the output will be this. Pretty cool. So quick summary, with React, we can create our own components, we can nest components as we like. Stateless function components are pure in terms of functional programming, and we can control the flow. So it's pretty cool. One thing is missing, interaction, because just rendering static stuff is cool, but yeah, not what we probably want. So what you can do is also with elements, you can assign action handlers, in this case an on-click. So if I would render that button, click on it, React would actually do the console log clicked. Question is how, when I say we have everything functional and we don't want to have state in our components, what do we do with such interactions? And that's the part where Redux comes in. And Redux is there. It's a small library, really small. If you take out all the comments, you have just like 120 lines. But yeah, it takes a little bit to understand what it's actually doing. But it's really nice. Just allows you to manage state of your application, and that with a predictable behavior. Now I want to explain you a little bit about the concept behind it, and therefore I want to get go a little bit further to the history of web development, because what we do with our backends is what we pretty early on figured out is let's make our applications stateless. So when a request comes in, it pipes through the application. Then we have a store, which is Postgres, MySQL, whatever. We dump all the state, our data and data state in there, and then we return a result. We don't necessarily return the whole state, some part of it, but it's always like you can deploy your application onto a server, and the thing is, it's not storing any state. We always put that stuff into some kind of other tooling or service that we use. So it's either Redis or MySQL or Postgres or whatever. If you have state in your application and your server crashes, you lose it. That's why we don't do that. And it's also pretty cool because we know we have one thing which we can ask, cool, what's the actual state? What's the data of our application? And that's the same principle in Redux. So what we have in Redux is we have one store object where we store everything that is related to the application. That's the idea behind it. And same as with backend request, you have basically your database state, the request comes in, and what happens is you modify your database and there's a new state. And then the backend sends part of the state back. With Redux, it's the same principle. We have our previous store, we have our action, and then we get to a new state. And probably by now you feel like this. Oh my God, are you crazy? But then, I want to show you a demo with time traveling. And that sounds really fancy, but there's a pretty cool tool, which is the debug or Redux debug DevTools. DevTools, yeah, exactly. So what you can see here, I actually have the complete state of my application in this Redux DevTools, and that's a simply to-do list. And I actually should call my mom. I definitely should make a task for it. And what you can see here is we added a new action, which is add to do. You can see the action. The action is the type of add to do, and you can see the text is here. So that's call mom. And what happened is from this previous state, plus the action transformed it to a new state. So while we previously had only one to do in there, now we have two. So you can see here, call mom is the first one, and the second one is use Redux. Cool. Let's add another one. Okay, we added another one. What about Redux? Use Redux? We've done that. Let's check that. So you can see, can have different actions here that manipulate our application state. And yeah, that gives us the power of, I can actually replay things. So I can just by click here, I can say, okay, from my previous state, I'll go back there. And what it actually does is it saves the initial state and then replays all the actions on top of it. And you can actually get to this state. What we also can do is we can go back in time and we can simply replay our things. And if you think about UI, front-end development, that's really cool. If you don't have to do the backend request again, but you just click, oh, that's how the data populates my application. That's really powerful and makes development really easy. And you actually can say like, oh, I want to leave out just something in between. All right, that's pretty cool. Yeah.
Short intermediate question about that is, and you should probably repeat the question for the mic. How, when you click something on the right, how is the undo done?
It has the initial state. Okay, how is the undo actually done in the code or with the data? How it works? It actually it has the initial state. It keeps the initial state, and then it saves the actions, and then it applies the actions on top of it. And then you basically do a replay from initial state again. And what you actually can do is, I haven't showed you that, you can say commit, and then you can basically set this as a new initial state, and you can do more actions again. That's the whole trick. So it's not actually reverting things, but it just keeps the initial state and applies things on top of it. Yeah. And so right now you feel maybe like this. I really want to have this superpower. And yeah, there's a couple of building blocks. I will really briefly go over them. I will explain the concept and just zip through the code. But the core of Redux is the store. The store basically connects everything. And the store has the state, which maps to your React component. And then your React components is basically your view rendering. And then the beauty of it is that you pass the state to your React component tree, and it will simply render the whole thing. As we have seen with interactions, what we can do is we can catch these interactions, we can create our action creators, and then dispatch an action, which is piped through the store, and then you have the reducers. And reducers are there. These are the things this is the code that you write to actually manipulate the data, because the thing, it doesn't know how to get from previous state with action to the new state. That has to happen somewhere, and that is the reducer code. So, and the thing is, every time any kind of action runs, either you get something pushed from the server and you dispatch an action, it will actually go through the whole thing and re-render the components. And you might think, okay, wow, that's really not performant, but because of Visual DOM and because of we just dealing with data in JavaScript, and even if you use immutable data structures, then it's super fast. You really don't have to worry about performance. And the beauty of it gives you a completely predictable, functional way of operating in the front end. An action, just an object. The only thing that you really need to have is type add to do. Action creator is just a function which returns an object. You can use it as, for example, in this case, I trim the data, and then we have the dispatch, which is coming from the store. The reducer, there becomes a little bit more interesting because, as you've seen, we get the state, which initially would be, in this case, the to-do list, would be just an empty array. And then what we do is we do a switch case statement. And when it's an action of type add to do, we return a new object where the initial list is in there. This is the spread operator, which takes the initial list, and then you simply append it to do. Feel free to ask me later after the talk if you want to know more about it. The core of it is the store. It's just an object which allows you to subscribe to it and dispatch. So what everything is piped through the store. The important part is that the store obviously has to be initialized with the reducers to make it understand that the store is initialized with the reducers. So when you dispatch an action on it, that it actually can figure out, oh, okay, that's the reducer that has to run to actually change the state that I'm storing. And then there's a little bit of you can use Redux with Angular, you can use Redux with anything you want, but it really works well with React. Any other kind of virtual DOM implementation. And there's a little bit of connection code you have to write. In this case, I have a provider component which is coming from React Redux, and then I have to put my store there and then wrap my component, which then gives us the dispatch that I mentioned before. That's better sit down and look at it when you have peaceful 10 minutes. So as a summary, Redux allows you to manage state in a very predictable, with predictable behavior. And the core concept is that you always go from one global state with an action you transform to a new state. Probably you ask yourself, why should I do this? As a reminder, reusable components, it's really, really useful. You have predictable code, very functional. You get things like time travel. So actually, if you want to implement time travel with this stack, you can do it in 30 lines of code. That's pretty nice. And it's very performant and lightweight. Way React plus Redux is like, I think not even a third of Angular or whatever. So it's very, very lightweight. Of course, you don't have a router in there and all the kind of features, but then you're in the whole community, you have a lot of stuff that you can leverage. Biggest question, is it production ready? Yes, it is. React is used by Facebook, Firefox, Airbnb, many more, Netflix. Redux, that's the more interesting question. Yes, the Firefox dev tools are actually rebuilt in Redux. The Docker internal platform, when you see your Docker images and so on, this is built with Redux. Even a technical university, I found an app which is built in Redux, MetaMark, and many more. And if you ever heard of Flux, there's two successors to Flux, I would say. I think you can say that, or at least I would. And first of all, Redux, and the second is Relay. But Relay from Facebook has, you need GraphQL and you need a lot of things and it's bigger data state management stuff that you have to buy into, and Redux, it's really easy to start from and predictable. Last but not least, we have a Vienna React meetup. Next one is on 16th December. A guy from Runtastic is going to talk about how they used React Native within Runtastic. And yeah, it's going to be here. And then that's it. Thank you very much. Any questions?
I have a question concerning the Redux state. Does it work together with the React state, the state of a component, or does it completely replace the React state? Do I have to say set state and hand over the Redux state, or don't I have to do that at all?
Yeah. It really depends. I mean, ideally, what you can do is you can write everything pure, and you don't use React, the React internal state at all. But obviously, in some cases, it might be useful. For example, if you have a drop-down menu, that's not something that you necessarily have to put in your whole application state, because it's not really data that is relevant to you. And in this case, you could have a component which internally uses state to say like is open, closed, and depending if you click user. But everything that is like, and if you have a form, you could have one component that is actually collecting all your data, and then you only dispatch an action when people click on the form. But then that's really related to usability. If you want to have an autosave, which is like with a timeout, and every like 10 milliseconds or probably too fast, but 100 milliseconds you do autosave and dispatch an action, save whatever is in the form right now to the Redux store, then you need the dispatch action anyway. Yeah.
Okay.
So, but I mean, the idea is that you actually can use Redux and only write pure components, and the beauty of it is that you use data as effects, or effects as data, yeah. And that makes it really predictable, your application, because it always, people can look at it, go down the tree, and you know exactly what's happening.
Okay.
Cool. Any other questions?
What do you use Angular with React, or because you mentioned Angular? Or what is your
tough
preferred?
one. I never tried it, so I'm probably not a good person to tell. You could replace the rendering layer of Angular. It would give you some benefit, but yeah.
But what's your preferred stack with React and Redux for all the things that React doesn't handle?
React Router, Webpack, hot reloading, then Redux. Then what I definitely encourage you to do is use Immutable.js. It's a little bit of a buy-in from your team. You have to be consistent doing it, because otherwise you get into a weird state of where you have immutable data mixed with non-immutable data. But if your people are good and they can take care of it, then it's just the best. And the benefit is actually that even React performs faster with using immutable data structures, because it can bail out earlier in the rendering tree. And that's actually the reason why ClojureScript, when working in a React application in combination with ClojureScript, by default is faster than if you do it with JavaScript, because you can't make this
You can't do this optimizations.
Yeah.
Okay. Good talk. Thanks.
Cool. Thank you very much.
Thank you for watching this talk. Down below, you can find our channel, ViennaJS, where you can find a lot of different videos about front end and back end JavaScript. And feel free to subscribe.